All right, so today we're gonna be talking about pH scale calculations, okay? Yes, it's gonna be math, but it's gonna be very, very easy math. So first off is you have already seen that acid bases form hydronium, which is our H plus ions, and hydroxide, which is our OH1 minus ions. Now, acids we know that forms our hydronium ions, so our H plus, and bases form our hydroxide ions, which is our OH minus. Now, every acid-base solution has a certain concentration of hydronium and hydroxide ions, okay? Now, acids produce more H plus than OHs, and bases produce less H plus and more OHs. And since all acid-base solutions contain both ions, there's an ionization constant of water, which is Kw. And that is kind of like we'll use this equation to, if we're given OH1 minus, we can find our H plus concentration and vice versa of a solution that's an acid or a base. Now, you can also determine if a solution is an acid or a base by finding or calculating its pH value. Now, for acids, the pH is going to be less than 7, and for bases, it's going to be greater than 7. Now note for distilled deionized water, so not tap water, but if it's deionized, so taking out all the ions from the water and it's distilled, the pH will equal to 7. Now pH is another way to indicate the concentration of hydronium ions. Hence pH, H represents the hydronium. And we'll be using these two equations. If we're given pH, we need to find hydronium concentration, or if we're given hydronium concentration, we could find pH. Like but opposite of pH, there is POH. And acids that have a POH value is going to be greater than 7, so it's opposite than the POH. And the base's POH will be less than 7, so very opposite to the POH. And the POH is another way to indicate the concentration of a hydroxide ion, hence POH, OH hydroxide. And we'll be using those equations. That parentheses here is supposed to be A0. So that's my bad, that is a typo. Now, since all acid-base solutions contain both ions, the pH and POH sums up to 14. So if if you're given pH, you need to find POH, or vice versa, you can use this equation. Now, here is a graphic organizer that we will be using for this class. So let's say you're given POH, you need to find concentration of H plus. What you can do is you can follow this graphic organizer and it'll tell you what equation you will use for that.
Alrighty, so let's go ahead and do some examples of using pH scales and hold all those equations in a problem. So we have a problem that says if a solution has an H plus concentration of 1 times 10 to the negative 1, calculate the OH minus, pH, and POH of the solution and determine if it's an acid or a base. There's a quick error in this problem. It's supposed to be the unit for this is supposed to be M. So we're going to go ahead and put that there. So because unit for concentration, as we know, is molarity, which is a capital M. So what we have right now, what we're given is our H plus. So if we look at our graphic organizer, let me go and zoom out for this. We are given our H plus on. And we need to find pH, POH, and concentration of OH minus, all three of these. So what's really awesome about this graphic organizer, like I said before, is it tells you what equation you're going to use if you're going from one variable to another. So since we know our H plus, we can either go to OH minus or we can go to pH. It doesn't matter which one we start off with because we're still going to get the same answer at the end of the day. So for this problem, let's just go from H plus to OH minus. So we're going to solve for OH minus concentration. And it says we're going to use this equation here. So let's go ahead and write out this equation. Alrighty, so we're just going to go ahead and plug in our H plus value, which is known as 1 times 10 to the negative F. So pretty much we're doing the same thing as solving an basic algebraic equation where we're just going to go ahead and solve for x. This is our x value. We want to get this one by itself. It's right now being multiplied by the H plus concentration here. To undo a multiplication, we're just going to divide. And those cancel. Now, this seems very complicated. Like, how the heck do I plug that into my calculator? Well, all of these values, actually, you don't need to use your calculator to calculate any of these, because since these are both 1 times 10, all we do is just subtract the exponent. So we're just going to take negative 14 minus negative 1. Negative 14 minus negative 1. We know a negative and negative, these two become a positive. So negative 14 plus 1, I owe someone $14. I have $1. That means I still owe $13. So our OH minus concentration is, again, we still have that base 1 times 10. And this is going to be our exponent. Oops. Let me go ahead and get my white out so we can correct that. Actually, let's just go ahead and do 1 times 10 to the negative 13. That's all you need to do for this. And again, we know it's going to be m as our unit. So now that we got our OH minus, looking back on our graphic organizer, we just solved for OH minus. Now we could just continue on with the triangle till we get back here. OH minus, now we want to go to POH, and if you go to the arrow that goes from OH minus to POH, it says POH equals negative log of OH minus. Let's go ahead and write out that equation. Again, we know our OH minus. Let's go ahead and plug it in. All right, so we got sorry, that's another error. Negative log of 1 times 10 to the negative 13 molarity. Again, we do not need to plug this in the calculator, because when you have a log of 1 times 10, anytime you have a log of 1 times 10, the exponent is going to be the answer. So what this equals to is negative, because don't forget this first negative, right? The negative log, so don't forget the negative. And we got negative 13. And remember what we just said, a negative equals a positive? That means our POH is going to be 13. Simple as that. So whenever you do a log, the exponent is going to be your answer. Still, don't need my calculator at all to calculate anything yet. So we just finished solving for our POH. Let's go ahead and solve for our POH. And that going from pH to pOH, it says that pH plus pOH equals 14. We just said our pOH is 13, so let's go ahead and plug that in. Again, we got to solve for pH. Right now, I need to get this by itself. Right now, it's being added by 13, so I'm doing addition. We're going to subtract. And what we get is I'll write the answer over here, pH, since these two cancel. 14 minus 13, we already know that is 1. Again, did not need to plug anything into the calculator because I could just use my mental math because it's really all it is just adding or subtracting. So it said we needed to find our OH minus. We got that there. We need to find our pH. We got that there. And we need to find our pOH. We got that there. Now it says determine if it's an acid or a base. Easiest way to do that is, well, we know that for an acid, the pH is going to be less than 7. Oppositely, our base is when our pH is greater than 7. Well, we have a pH of 1. 1 is less than 7, so we have an acid as our final answer. So let's go ahead and do one more examples of this. Just adjusting my camera here. Alrighty, so now we have a problem that says, if a solution has a pOH of 8, calculate the H plus, concentration, OH minus concentration, and pH of the solution, and determine if it's an acid or a base. So this time, we're only given our pOH. So looking at our graphic organizer again, we are only given our pOH, and we need to find pH, concentration of H plus, and OH minus concentration. We have to solve all 4 of these. So again, we can go ahead and pick whatever path we want. We can either go from pOH to OH minus or pOH to H plus. Let's go ahead and do an easier step going from pOH to pH first. And that we're going to use the pH plus pOH equals 14 equation. Again, our pOH is 8, so we're just going to plug that in. We need to solve for pH, so we need to get that by itself. So to undo, right now it's being added to 8. So to undo an addition, we have to subtract to both sides. When you do that, 14 minus 8, we know, is going to be 6, just using mental math. I mean, you can use the calculator to figure out what 14 minus 8 is, just to reassure yourself, but that would equal 6. So we already know our pH, so that's already done. So we just ended at pH, so now we have to go to H plus. So the arrow that goes from pH to H plus says we're going to do the concentration of H plus equals 10 to the negative P, pH. Okay, so that's the equation we're going to use. We already know our pH is going to be 6, so we're going to plug that in. And we already solved the concentration for OH minus, because doesn't this look very similar to 1 times 10 to the negative 13 or 1 times 10 to the negative 1? It does. The only difference is it doesn't have one times, but we can always write that out there. So that would equal 1 times 10 to the negative 6. And since this is concentration, we still need our capital M. There you go. So we just finished calculating for H plus. Now we have to do one more step to find OH minus, and we're going to use this equation again. We're going to go in and plug in the OH minus concentration we just solved for into this equation. And again, we need to get H plus by itself. It's right now being multiplied by the concentration of hydroxide. And again, to undo a multiplication, we're going to divide it to both sides. Again, we don't need to plug this in because they're both 1 times 10. So we could just go ahead and take the exponents and subtract them to get the exponent for our answer. So we have negative 14 minus negative 6. Again, a minus and a minus equals a positive. So negative 14 plus 6 would equal negative 8, because we owe someone $14. We only have 6 right now. That means we still owe $8. And this is the exponent to our answer. So our answer is negative 8. 1 times 10 to the negative 8 molarity. We found our H plus, we found our OH minus, we found our pH. Now we have to determine if it's an acid or a base. Again, we know that an acid has a pH less than 7, and a base has a pH greater than 7. Right now we have a pH of 6. 6 is slightly less than 7, so we still have an acid. And that is how we do these problems. Alrighty, so go ahead and do this problem on your own. And here's your answer. Again, you could have gone a different direction. You could have gone and solved for POH first, but what I did is I solved for H plus first. Go ahead and try this problem on your own. All right, and here's your answer. Again, I decided to solve for H plus first, but you could have solved for POH first if you wanted to. All right, and that's it. Thanks, guys.